Hello, welcome to Mathy Python. In this video, I talk about the solutions to the problems in the working with files. So first of all, you have to change your directory to whatever directory you save the workbook and the data to. So you use cd, tilde is on a Mac, it's users, Mark Pedigo in my case, that's my home directory, and then the rest of this. So I would tell you what that is, but I don't know where you saved it. So find that out, put that in here. So you change directory to that. And you need to do that because I'm going to refer to this data directory using relative addresses, so that I don't have to type this whole thing every time. So I'll just use this as my home base and then use the data from there. I'm going to save everything to an out directory. This code doesn't really matter how it works, but it creates an out directory if it doesn't already exist. So I run that cell, and here I have an out. Nothing in it yet, but here it is. All right, so I'll come back to the state line in a minute. Looking at line 3, I open the file. So I will open a file called out in the out directory, hello text, and I will open that as writing and give it a file handle of F. Now that file doesn't exist yet, but that's okay. The W will write that file. It will overwrite whatever file with that name. So be careful with it. And then I write my name. I want a new line because I want this to be on its own line. So I put a new line in there. Then I write today's date. You could just use a string, but I got fancy with it. So there is a date time module in the standard library, and you can pull today's date out of that. Then I have to cast it to a string. It saves it as something called a date time object. Then I write a new line, write Mathy Python. Okay, and then I kick out of this block. When I come out of the block, the file is closed, the file handle goes away. Now I'm going to open up a new file handle for that file we just created, but this time for reading. Once I've done that, the contents is fread, that reads the entire file, and then I print it out. And you can see that reading the file, I have my name, the date, and Mathy Python. I can go in the out directory, double click hello text. Here we're looking at the file itself, not just a read out of it. Number 2, read the scores CSV from the data subdirectory. So in the data subdirectory, there's something called scores CSV. If I double click on it from here, it shows it to me in a spreadsheet format. I can right click and say open with editor. Underneath the hood, this is a comma separated value file. That's what CSV means. So I just have data and then a comma and then data, and then the next data point starts on its own line. So if you look at CSV files that you import into Excel, this is all there is to them. With Excel itself, you can save things as a CSV as you want. If you want, it uses its own format otherwise. Okay, so open the file. Line equals Fread line, singular, no S, so it just reads one line, and then I'll print it out. There it is. So that's the header. Number 3, read scores CSV line by line and print only the students who scored above 85. So I open up that file again as F. This comes in handy if you want to skip the header, or if you want to skip any line. The way to do that is next, and then your file handle, and that will skip the next line. So this is used very commonly, like we are here, to skip the header if you don't need the header. Then for line in F, so that will iterate over the lines, I split it. That's line.split. And if the score, which is in index position 1, see its name and then it's the score. So if fields sub 1 is greater than 85, then print. I use the strip to strip off new lines and extra spaces. When you print puts its own new line in there. So if you don't strip it off, you'll get 2 new lines. Like that. So just to make it print better, I'll just put strip. Number 4, write a program that appends a new student entry to new score CSV. Read the file back and verify the new entry appears at the end. Yeah, so I'm going to open up the new scores, a file that I created, get its contents. Then I will create a file also called new scores, but I'll put it in the out directory there. And use it for appending. So first of all, I write the contents, make a copy of that, then I put a new line, then I append to that file. So I can write zfod74c. Then I'll validate that the new line is in the file, what is the difference between opening a file with W or A? So this is write or append. Write a short program that demonstrates that W overwrites and A does not. So I'm going to create a file called demo for writing. I'll put in some stuff, more stuff, then print it out. Then I'll append a line, yet more stuff, print it out. And then I'll overwrite with this line overwritten, then print that out. So what happened here, I opened a file called demo text, wrote in some stuff, more stuff, some stuff, more stuff, printed it out. Then I pinned a line, and it has the first 2 original lines and one more line that's appended to, so it did not overwrite. Then when I use the W, all of this gets blown away and it's replaced with this one line. Number 6, read scores.csv and compute the average score. Print it rounded to 2 decimal places. Don't hard code the number of students. Okay, so I open up data scores.csv, that one. Number 6, read scores.csv and compute the average score. Print it rounded to 2 decimal places. Do not hard code the number of students. So I open up the file. Here I skip the header. Then the logic, total in the count are initialized to 0. Read in the lines. Split that so that I can get the individual fields. The score is field sub 1. Cast it to an integer, add it to the total. Increment the count. Compute the average is total divided by count, and then I round it to 2 decimal places and print it. Number 7, write a program that reads scores.csv and writes a new file, report.txt, containing a summary, total students, average score, highest score, lowest score, and the name of the top students. So in line 1, I open up the file, give it a file handle, skip the header, initialize total count, highest score to very low number, top student to empty string, lowest score to a very high number. And then for line in F, read the line, split out name score, add the score to the total. If the score is greater than the highest score, then the highest score should be that score. That's higher than the one that's stored in there. Top student is that name. If score is less than the lowest score, then it's the new lowest score. Increment the count. Compute the average score, which is total divided by count. Then I open up, I create actually this report.csv. It's W, so if you've ran this before, it'll get overridden. And then I write out a header line, count average score, etc., and then write the values with that using an F string. Number 8, write a program that reads a text file and counts the number of lines, words, and non-white space characters. Test it on data text from the data subdirectory, print the results. So I open up the file, read the contents. From here, I'm done with the file. I'll just manipulate the contents. So I print them out, calculate the number of lines. So calculate the number of new lines, calculate the number of words. So split the contents on a space by default. Number of words is the length of that. For the number of characters, I add the length of each word to that. Then I'll print the number of lines, number of words, number of characters. Number 9, read scores for pass-fail CSV. Write a new file, pass-fail CSV, with the same format, but add a 4th column result that is pass if the score is 60 or above and fail otherwise. The header row should be name score result. Print a new file to verify. So I read it. So I open up the file with the file handle, skip the header, and then the lines. The rest of the lines are file handle dot read line with read lines plural. So that reads the rest of the lines. Then I create this file with the W. I'm going to put it in the out subdirectory, call it pass-fail CSV. I write the header, name score result, iterate through the lines, strip out the white space, the fields. For the fields, I split it on comma because it's comma delimited file. Pull out the score. If it's greater than 60, then I append pass. Otherwise, I append fail. Write this as a string now. So the fields join together with a comma, and then I put a new line on the end. And then read it back out. There it is. So now we have the name, the score, and the result. Number 10, write a robust file reader. A function read CSV file name that returns a list of dictionaries. 1 per row using the header row as keys. For example, the first row of scores. CSV should return name, Alice, score is 92, grade is A. The first header row is name, score, grade. So I'm going to use this as the keys. I'm going to use these fields as the keys. And then the first line would be a dictionary. So name, Alice, score is 92, grade is A. So that's saved as a dictionary. Handle file not found error gracefully. Okay, so I put it in a try except block. The except block, the file not found error, print that file is not found, and then return an empty list. Otherwise, we say the result is, it starts as an empty list, and then we will populate that. So we open up the file for reading. The keys is the first line, the header. So I read that line. I strip out the spaces. Then I split it on the comma. Then for line in our file, the fields, split those on the comma because it is a CSV file, comma separated. So that will give me a list of the fields. Then dictionary, initially empty. And then for I key and enumerate the keys, the dictionary of that key, which were created from the header file, is the fields. Then append that to the dictionary and return it. Number 11, read data text, count the frequency of every word, ignoring case and punctuation, and write the results to word frequency.text, sorted from most to least frequent. Each line of the output should look like some word, then a colon, then the number of times it appeared. Use this line or similar to sort the dictionary. Don't worry about how it works for now. We'll cover lambdas in the intermediate course. Just take it on faith right now that will work. So I open up the data file. Frequencies as a dictionary is initially empty. I iterate through the lines in that file, split that line for the words, iterate through each word of the words. If the word is already in our frequency dictionary, then increment the count by 1. Otherwise, initialize it to B1. And then use this magic line to sort the dictionary. Then I write that information to a file that I'll call word frequency text. Open up it as writing. For word frequency and the frequencies, I will write the word, then a colon, then the frequency as a string, and then end that line with a new line. And then let's open it up and read it to see if it did it. And sure enough, we get Python showed up 3 times and 3 programming 2 at 2 and so forth. Number 12, CSV to report. Read scores CSV and write a formatted report to report.text that looks like this. I give you a format. So we open it up. We skip the header line. Initialize total count, top name, and top score. Open up our report as another file. This open as a write is nested within the open as a read. So I do actually need 2 variables here. If I used F, it would get confused because you're using the same handle for 2 different things. So I write out a student report and the header, iterate through the lines, split the line to get the words, pull out the fields, write those in a format, add the score to the total, increment the count. A little bit of logic to calculate the top score. Once I'm out of the loop, the average is the total divided by the count. Then I write line, and I write the average and the top score. And then let's read it, see if it worked. And it did. If you don't believe it, you can go to the out file, report text. There it is. Right, so in the real world, it's very common to have data sitting in files of some sort. So you get you read in your input data, then you process it, you do whatever you do with it, and then you write that out to a report, which you'll probably also want to save as a file. So this is a very common thing to do. Number 13, read data text, build an inverted index. What do I mean by that? A dictionary mapping each unique word to the list of line numbers it appears on. Write the index to index text, 1 entry per line, and sort it alphabetical. So, for example, here the word Python appears on lines 1, 3, and 5. So I open up the data file. The word index is initialized to a dictionary, empty dictionary. Iterate through the file. I want an index and also the line. Get the words by stripping that. For word and words, if the word is in the word index, then I append I plus 1. I starts at 0, and I want this to start at 1, so it's off by 1. So that's why there's a plus 1 in there. Else initialize that. The word index dictionary of that word is whatever. Yeah, and then write that to a file. And let's read it to see if it worked. And it did. So Python appears on lines 1, 3, and 5, is on line 1, A on lines 1 and 5. I hope you found these problems challenging and useful. Yeah, dealing with files, it's not the sexiest thing, but it is used ubiquitously, and it is, yeah, it's just something that you'll do all the time. So it's worth knowing how to do this stuff. Thanks for watching. Catch you in the next one.